KE Lab, part 1. And this first video, we're just going to give you a little bit of background, and then Enzo and Ratisha are going to show us some of the procedures, and then we'll do a follow-up video with some of the calculations and things, and a summary of the data that we have. So just a couple highlights before we go to our star presenters and lab demonstrators. We are going to look at prepare the standard solution. So we only have 2 of them today. One is 0.20 molar iron nitrate, and one is 0.0020 molar KSCN. So the KSCN is a lot smaller concentration. Note that it's also, instead of completely in water, it's actually dissolved in an acid, and there is a reason for that too. So with that, I'm going to kind of go to the second page here, or maybe the third page, and point something else out. Here's an equation, and this is similar to something we've done before, where we've taken Fe plus 3 for KSCN, and I'm going to show this, which is a clear solution. And I'm going to take a couple drops and put it here. And then I'm going to add FeCl3. And I think we did this in an equilibrium lab a while back, probably in honors chem. And it gets this really intense blood red solution that we're looking at right there. But notice this Fe plus 3 has a color yellow. So we want to make that clear. And that's why you got this Fe plus 3 plus SCN minus forms FeSCN plus 2, but it's under acid conditions, which clarifies this, and it takes most of the yellow color out. There's a little bit of dinginess there, but not too much, okay? So it gives us a lot better background to analyze our red color versus a clear or mostly clear solution. The other thing going on in part 1 is we have a lot higher concentration of Fe plus 3 than HSCN. And the reason is we want to essentially use up all the HSCN. So if we know the concentration of HSCN, we're going to say that that's all going to convert to FeSCN plus 2. Then we'll know the concentration of FeSCN plus 2. And if we know the absorbance and we know the concentration of FeSCN plus 2, then we can match concentration of FeSCN plus 2 to an absorbance and create an absorbance curve. Where in part 2, we can take unknown solutions of these things, use our absorbance curve to know the concentration of FeSCN plus 2, and then solve other parts of the problem and ultimately figure out an equilibrium constant. Okay, so that is a lot. Now, what they have been doing today is essentially this big piece right here, using a burette or pipettes to measure 2, 3, 4, 5, and 6 milliliters of KSCN, and then they're putting it into, and then adding it to the FeNO3 solution. So we'll come over and maybe take a little look at this right here in their setup. Let's see, I'm gonna stop my share, come over, and we'll kind of do this. Oops, almost got my cord plugged in here. So we're gonna come over here, and Ratisha, can you see yourself in here?
Yeah.
Okay, so Ratisha is gonna take, do a little pipetting. She's drawing up that pipette, okay? Enzo, as long as you're standing there, is it a good idea to mouth pipette? No. No, good answer, good answer. So we don't mouth pipette. She's gonna draw up to getting at least 6 milliliters. Is it there, or do you need a little bit more?
I think I'm good right now.
Okay. So then she's drawing it back down, and she's going to put that in. Okay, now she's going to take it over and transfer it over to this container there. Okay, let's see if we can take a look at this. Can you see yourself right there? Are we good?
Yeah.
Okay, so now she's transferring it in there. And so there's 6 milliliters of the KSCN, and that's clarified with the nitric acid as everything is. And then she's topping it off with, well, it's going to be probably 94 milliliters of FeSCN, the more concentrated one. And I didn't give them a lot, so hopefully there's enough to get there. And there will be, but it's pretty close. And again, now it would be nice to have what we call a volumetric flask to do that with. And that actually has an etch mark. Now, my concern is that some of that Fe plus 3 might be on the bottom or I'm sorry, the SCN there. So we're going to try to mix it, and we're going to do some mixing. She's going to go back and forth a little bit to make sure that that's balanced. Maybe one more mix. Oh yeah. And now it's a uniform color. So we gradually went, if you look here, from 2 to 3 to 4 to 5 to 6 milliliters. And it's kind of hard to tell, but I think this one looks the darkest and this one looks the lightest, and that's what we expect. Well, instead of saying this one looks the lightest and darkest, we're going to put a value on that, an absorbance value. So that's what we're going to do next with the spectrophotometer. So I think you had a blank, is that right? And we came over here with a blank and we put it in here. And essentially, what did we do? We opened up, oh, can they see this okay?
Yeah, they can.
Okay, so this is a spectrophotometer, and they put a blank, and why don't you lift up that cuvette right there? And we're gonna only touch it, and you can pick up the thing right there, and you can hold it up there.
I can bring it
You
up.
can bring it out, yep. Okay, so there's a beam of light that goes right through the middle. So we either touch it high or touch it low, but not there. And we always line it up on the yellow, on the white thing, so it's kind of moved around, and it's always going through the same part of glass in case I could throw things off. And what I did was I threw my blank was, instead of distilled water, I used just the Fe solution without any stuff in, which was mostly clear, but there's just a little dinginess. So that's going to be our blank. And we're going to go ahead and put that back in. We're going to set our transmittance to 100% after we put that in. Okay. And we set our wavelength right. Oh, just a second. Why is that moving off? That's really weird. Okay. The same thing, right?
Yeah, should
Oh,
be.
there's a little speck of water on there. Does that look like a speck of water? Is that a bubble?
Go grab. I think it's on the outside.
You think it's on the bubble? Grab a little cloth. We're gonna wipe this off. Just no problem. Just wipe the whole thing down.
Ooh, it's not on the outside. Yeah, it's a bubble.
It's a bubble. Okay. Okay, that bubble popped. Okay. In this case, I'd like to burst your bubble. Okay. Oh, that's matching up a little bit better. So you can see how odd things can come up, and then maybe just adjust your transmittance. I think we're at 98. You want to do that? And this is pretty fine tuning. I think we gotta go the other way. There you go. And again, you might get it 199 or 100. That's pretty good if it's oscillating back and forth there, right there. So that is going to be our transmittance is 100%. Okay, just do a little tweak here. Watch, I'm going to screw it up here. I'm going the wrong way. Okay, our transmittance is 100%. That would be 0% absorbance. We're going to do things in transmittance and then do a conversion to absorbance. Okay, now what they're going to have to do is go grab another test tube. Go ahead and pull this one out. Actually, they're going to use the same test tube, and they're going to put in one of the solutions. So the blank went there. Now they're going to go to the 2 milliliter one, or what we'll call solution 1, which had 2 milliliters of the KSCN, and it had 98 milliliters of the other one. And they're going to rinse it a couple times with the solution they're going to use. So you rinse those out a couple bit, and yeah, you can even pour straight in there, I think. You can give it a pour. You can pour it in there. Be daring. It'll be quick. Do a rinse, fill it up, and dump it out. And the reason they're rinsing it like that is to make sure that it actually has just the solution they're measuring. So we only need like 5 milliliters. We have 100 milliliters. We can waste this. It's okay. And then she's going to fill it, 2/3 of the way full. And now you're confident that you can do this really quickly like that. What you will want to do is wipe down the sides, because we saw how water can affect things. So wipe that down real good. Keep things off there. We're going to take our first absorbance, and I think this will probably give you a pretty good idea how this is going to work. Ultimately, after this is done, we're going to get all the other data, and then I'll put a video with the data and how to do the calibration curve. So we close it up, and the number, or don't touch it, don't adjust it, because we know it was 100 now, and now you're going to write either 68 or 69. It looks like it's hovering between the two. So you can write that down, okay? And then we're just going to go do the other ones. I think I'm going to sign off for now. We'll come back with the data and our next video and how to do the calibration curve there. All right, thanks. Great job, Ratisha and Enzo. And I will end it now.